Hello everyone, today we'll be learning about functions, the first chapter in additional maths syllabus. There are four things we will cover today. Firstly, I'll teach you about the terminology, which is very important in this particular topic. Second, we're going to learn about what relations are. Thirdly, we're going to talk about what exactly is a function and what makes a function a function. And lastly, we're going to learn how to use functions and how to obtain values we want in an examination. So let's get started. But before we get into the content, let's just talk about what exactly is a function. A function helps us to connect two groups of data. For example, here we have one group of data here and another group of data here. A function then helps us bridge the gap between these two. It tells us what the relationship is between the first set of values and the second set of values. Here, I'm not sure if you can guess, but if I draw the lines, if I connect the data like this, it's quite obvious what the relationship is, right? Each data point in this first set is one less than the data points in the second group of data. So we can express the relationship as fx equals x plus 1. This basically just means that in order to get from this data to this data, you have to take the data in the first set, which is represented by x, and add 1 to it. So for example, to get from 2 to 3, we just have to add 1 to that value. So that basically is what a function is. Very simple. Now, let us talk about some terminology. Here I have two sets of data. By the way, the data doesn't have to be numbers, it can be anything. And here I'm going to use names and people. But of course, in your SPM examinations, it's almost always going to be numbers. So in this case, I have two sets of data. First is a group of people. Let's call them Team Iron Man. And the second group of people, Team Captain America. And this value is going to, these two sets of values are going to be connected by the relationship of fights. Right? So each character in the first set of people is going to fight someone in the second set of people. So this is a very good use of terminology. But let me just try to connect the dots first. So I think in the movie, Tony fights Bucky, Natasha fights Hawkeye, Vision fights Wanda, Rhodes fights Ant-Man, and Spider-Man fights Steve, I think. Right. So now let us just talk about how we're gonna, what the terminology is for functions. First of all, each data point in the first group of objects is called an object. And each data point in the second group of data is going to be called an image. And the whole of the first group of data is going to be called a domain. Alright, so for example, in the domain, there is Tony, Natasha, Vision, Rhodes, and Spider-Man. And each of them is an object. However, in the second group of data, it is not called a domain, it's a codomain. Right? And the codomain encompasses all the data in the second set of values. However, I sort of lied when I said that each data point in the second set of data is an image, because there is one data point here which is not an image, and that is poor old Falcon. Falcon is a non-image. This is because it does not have a corresponding object. He's not fighting anyone. And however, Falcon is still part of the codomain. Remember that. Both images and non-images are part of the codomain. And one last thing we have to understand is the range. Range refers to all the images in the codomain. This means that the range only includes everyone else except for Falcon. Now that we've got the terminology down, let us go to explain what relations are. There are essentially 4 different types of relations. The first is a one-to-one relation. This basically means that each data point is only connected to one other image. This means every object only has one image. That's a one-to-one relation, easy enough. The second type is called one-to-many relations. Here, one object might be connected to 2 different images. So that's why it's called one-to-many. The third type, as you may have guessed by now, is a many-to-one relation. This means that multiple objects have the same image. That's why it's called many-to-one. And the last kind of relation is a many-to-many relation, which is essentially a combination of the second and third type of relations. So basically here you have both a one-to-many relation and a many-to-one relation. So you see there's a one-to-many relation here, one-to-many, and a many-to-one relation here as well. And both combined, that becomes a many-to-many relation. And now to talk about what actually a function is. The only definition you need to memorize for what a function is that every object, and the keyword is every object has only one image. Right? There are 2 keywords here, every and only one. So let's talk about what this means. Let's say we have 2 data points here, and in each set of data. If I draw one relationship like this is definitely a function because every object has one image. Every object has one image. However, if I erase one of the relationships and I draw B to C instead, and A is left all alone, this is not a function. This is not a function, I repeat, because one object does not have an image. And as we know, the definition of a function is that every single object must have an image. How about another example? Let's just say we draw A to C and A to D. This is also not a function. So let me just erase B first. Let's assume there is no B. Here, there is not a function as well because this object has more than one image. It has 2 images. And from our definition, every object can only have one image. Therefore, this is not a function. Now that we know what a function is, let us actually attempt to use these functions. And these are the bulk of the questions which you'll get in SPM. So here we're given a function which is fx equals 6x minus 5. And we are supposed to find f2 and the image of 10. Let's start with number 1, which is f2. I'm just going to do it up here. So f2 basically just means we are putting 2 into our function and we want to see what comes out on the other side. In order to find out what comes out on the other side, it's very simple. All we have to do is use this function here and we replace the number 2 into x. So how does it look like? It looks like this. 6. And instead of x, we use 2 minus 5. We finish the equation and we get 7. Therefore, the answer for number 1 is 7. The second question is essentially the same thing, however, we're going in the opposite direction. Here, they're giving us the final value, and we have to find what the number inside the function is. Right? So this is very simple. All we have to do is rewrite the equation 6x minus 5, right? 6x minus 5, and that will equal to 10. because that is what the question tells us, the image of, oh, I'm sorry, there's a mistake in this question. It's supposed to be the object of 10. Right? So what the question is asking for is what do we have to put into the function in order to get 10? Right? So all we have to do is write 6x minus 5 and let that equal to 10. And from here we solve for x. Here I can bring 5 over, it becomes 10 plus 5, 6x equals 15, x therefore equals to 15 over 6. And because I'm lazy to find out what the actual number is, we'll just stop here. And I think that suffices as demonstration. So thank you everyone, that is all 4 functions. It's very simple, and these are all the essential things you need to know. And every question in SPM will just be a mere variation of these basic concepts that we've gone through today.